Sparse columns provide an efficient way to store data that's predominantly null by requiring no disk storage space for the null values. That sounds great, but it does involve a cost. In a field marked as sparse, the non-null data takes up a bit more storage space than if the field weren't sparse. And it amounts to either 2 or 4 additional bytes, depending upon the data type of the field. Microsoft recommends that you use sparse columns for fields in a table when you can save 20 to 40% of the total storage space. Probably the most common scenario in which sparse columns make sense is when the field contains a lot of null data and relatively few rows in the field contain data, non-null values that is. This often happens when the database supports an object relational mapping or ORM architecture, in which several concrete classes inherit from an abstract class, and the data is all saved in a single table. In that case, not all of the derived concrete classes use all the available fields, and you're wasting storage space even with null data. Now you can implement an ORM support database with multiple tables, but that's more complex and generally is harder to maintain. SQL Server has a number of restrictions on the use of sparse columns. There's a few that are probably the most important. One is that a sparse column must be nullable. Well, of course. It makes no sense to make a non-null column sparse because it can never include null data. Okay, so that's kind of a given. You can't use row GUID call or identity properties on the column. The column cannot have a default value. And you can't use a sparse column in a user-defined table type. These restrictions really aren't very onerous, but you also need to consider a few other things. You can't use sparse columns with all data types. Specifically, you can't use them with geography, geometry, text, end text, timestamp, image, and user-defined data types, nor with var binary max fields that use file stream storage. You also can't mark a computed column as sparse, but you can use a sparse column in the calculation of a computed column. You also could face difficulties if you need to change the table schema that contains sparse columns. Changing the schema requires some workspace within a row. So if the row size is near 4009 bytes, which is close to half the maximum size, adding or removing a sparse column can fail because SQL Server needs to make a copy of the data, but it doesn't have room to do that. In practice, you can save the data to a temporary table, drop and recreate the table with the sparse columns, then move the data back. A bit of a hassle, but not really disastrous. A table with sparse columns has a slightly reduced maximum row size, 8018 bytes instead of the usual 8060. SQL Server needs the additional space to manage the sparse columns. But the really good news is that you can have up to 30,000 columns in a table with sparse columns, so you can get just about as carried away as you want with the table schema. All of these restrictions really are pretty manageable, and generally don't severely limit the use of sparse columns. You have to be aware of them, though, in order to avoid problems. Before I explore the sparse columns code, I have some recommendations about their use. First, and most importantly, don't use sparse columns as an excuse for poor database and table design. Some uses of sparse columns denormalize data, which you should do only with good reason. In addition, look at the performance and storage changes for your data. You may or may not experience an improvement in either, depending on the nature of the data and the patterns of usage within your applications. Always, always, always use careful database design and implementation. As cool as sparse columns are, they're not appropriate for every scenario. In order to explore the features of sparse columns, I'm going to work with the dog table within the TempDB database. And here's the code that creates that table. It's a fairly typical table, has a dog ID, various characteristics of the dog, but then notice that I also use the sparse keyword to make a number of the columns sparse. The scenario here is that some of our dogs are pets, others are working sled dogs, and all have various characteristics to record. Some fields apply to all dogs, others just to the working sled dogs. And some of the columns apply in theory to all the dogs, but contain data for only a few. So now I want to run down each of the columns and explain my rationale for making it sparse or not making it sparse. Okay, first up is dog ID. This is the primary key identity column, which can't be null. For that reason, it can't be a sparse column. Okay, easy decision there. Name column also is not sparse. All of our dogs have names, so all the rows are going to have a value for this field. And in fact, it's marked not null, so this is definitely not a candidate to be sparse, because there's no null values. Okay, then last rabies. This is null, but not sparse. This is a date column, and it records the date of the last rabies shot for each dog. All of the dogs have current rabies vaccinations, except 2 that have specific medical conditions that preclude the shots. So explicitly, they're not allowed to have the rabies shots. Since this field will have data for by far and away most dogs, it should not be sparse. All right, next up is sled dog. This is a Boolean value that indicates whether the dog is currently a working sled dog. Some of our dogs choose not to be sled dogs, and some are retired. This could define a record type in an ORM system. The column doesn't allow nulls, so it can't be sparse. Then handedness, and this is the first sparse column in the table. This applies only to sled dogs, so it's already going to apply to only a subset of the dogs in the table. A sled dog can have a side preference when running, which they may push their running mate off the trail if they're on the wrong side. This applies only to sled dogs, and only a few of those have this characteristic. So this is a good candidate to be a sparse column. Relatively few rows are going to have a setting for handedness. All right, then birth date. Now, it might be a little surprising that this is sparse, but many of our dogs are rescued. I'm with a volunteer organization called Second Chance League, and we get some rescued sled dogs through that organization. Because they're rescued, it's actually pretty rare that we have their exact birth dates. That makes this a candidate to be a sparse column. But we'll really need to look at the actual data to see how many birth dates we really have. Okay, then there's birth year. Now this is a bit of a denormalization of the table schema, but sometimes all we have is the year they were born. So rather than try to force fit the birth date field with bogus month and day information, we record the year here if that's all we have. It's a candidate for a sparse column because it applies only to a few dogs. All right, death date. Don't want to dwell on negative, but fortunately most of our dogs that we're going to record in here are still alive, so we're going to have very few death dates. And then the weight. And this is sparse too. This might be a little bit surprising as well, because all dogs have weight. But the weight of our dogs, we really only need to track them if the dog has some medical condition that makes it hard for the dog to maintain weight. It's going to apply only to a few dogs. Fortunately right now, none. And so it's a sparse column. Leader. This is another field that is going to apply only to sled dogs and indicates whether he or she is a leader. So it's a sparse column. It takes special kinds of dogs to be good leaders, and we've been blessed with a number of really outstanding leaders. Okay, rescue. This is not sparse, even though it's a nullable column. This indicates whether the dog was rescued from the animal shelter or some other emergency situation. We always know whether our dog was rescued or not. Either or, we know at least where they came from the animal shelter, from an acquaintance, from some rescue situation out in a village in Alaska. You know, we kind of at least know the situation. Okay, so since this column is always going to have a value, it's not a good candidate to be sparse. Okay, ongoing drugs. This is also sparse. A few of our older dogs, or those with some long-term medical conditions, take one or more drugs for an extended period, and those are recorded here. This applies only to a few dogs, so it's sparse. And then spay-neuter, it's the final field. It's not sparse. All of our dogs are spayed or neutered, with no exceptions whatsoever. Only a new dog may not yet have been fixed, so this column is not a candidate to be sparse. We always have this information. Okay, so that explains kind of the rationale for why I made some of these columns sparse and why not. Now, To be honest, making any columns in this table is not going to be all that sparse. We currently have 20 sled dogs. That's not a lot of rows that are going to go in here. That's not a lot of data. It's not going to make a huge difference for the size, the storage space required by this table, whether they're sparse or not. But I want to explain the rationale and show you some of the techniques of sparse columns. Okay, so let's go ahead and create the dog table. We're in TempDB. Okay, so now the table exists, and I'm going to insert some values into that table. Okay, so as you can see, I have several insert rows here. These are just regular insert statements. Nothing fancy here. I have the fields that I'm going to include, and I use different fields for different dogs because not all dogs are going to have the same data. And the values clause contains the values. Nothing new or special about these columns. I don't have to do anything different in order to insert data into a sparse versus a non-sparse column. Okay, and by the way, a T-SQL row constructor wouldn't work well here in order to insert multiple rows of data using a single statement because I'm including different fields for each dog. Okay, could do it, but it was a little bit easier to do separate insert statements. All right, I'll go ahead and insert that data. And now we have a table with several dogs populating the rows. Okay, so we can take a look at the data and get a better feel for what's in there. All right, so all the rows have dog IDs, all have names, all have rabies dates, all indicate whether or not they're a sled dog. This particular set of dogs, we don't indicate any that have handedness. Have a couple birth dates, a couple birth years where that's the only information we know. These dogs, no death dates. A few dogs with weight. Some dogs with leader characteristics. Again, we always know if they're a rescue or not. And then a few that have drugs. And then they're all spayed or neutered. Okay, so for the most part, again, this is a very small number of rows. So it's not going to have quite the impact of a table with 100 million rows. We're not quite ready for that number of dogs. But you can kind of start to see handedness, definitely a candidate for sparseness. Birth date, a little marginal, but it's there. Birth year, a little bit more marginal. Death date, definitely candidate for a sparse column. Weight might be, leader may or may not be. And some of the columns, as you add more rows to the table, you might discover that there's more null data than you thought, and other columns may be candidates for sparse data as well. Okay, so I retrieved all of this information using a select star from dog. And this, of course, returns all of the columns. Not generally a good idea, so for the most part, you usually want to write select statements that explicitly define the fields that you want. Because frankly, very often you don't want to return all of the fields or all of the columns from a table within a select statement. So you can do that too. So same results. There's nothing different about using a select statement so far with using sparse columns. And then to emphasize the point, there's nothing functionally different about the table. Only the storage changed. So that means that also all of the usual insert, update, and delete statements work the same as with any other table that doesn't have sparse columns. And you can wrap operations and transactions as usual. So all of these statements operate as you'd expect. I can select star from dog and filter. I can select subsets of fields and filter. I can wrap the statements in a transaction and so forth. So I can execute this code and pretty simple kinds of transact SQL statements, they all work just fine. It's a normal table. But with a lot of rows, a lot of null values, it's going to take up less storage space.